So we are going to do a little bit of a review from section 2.4, which is inverse of trig functions. And also we are going to do some examples from 2.5, which is will be solving trig equations. Sorry, I have to take a minute of break. Okay, on questions from 2.4, we have some inverse function questions. Example of it would be, say, calculate sine inverse of 0.3. We can, of course, always do such a thing with the calculator. The intention of the text in this section is that you learn the properties so that you can answer any of these questions essentially all the way through 62 without the use of calculator. So let's see what is involved here. This is, what's the meaning of this? So when we write sine inverse of 0.3, what kind of entity do we expect to come out of this? Sine inverse always brings out the angle whose sine is the number that was fed to the sine inverse. So this statement is same as saying sine of theta is equal to 0.3. That's the meaning of that expression. So sine inverse of 0.3, you could find it on a calculator, but we can bypass that issue altogether. So this is certain angle. Well, what do you do? What do you want to do with this angle? You want to calculate the sine of it. Well, by definition, the sine of that angle is supposed to be this number. So the answer is just 0.3. You might go back and forth on your calculator. It might end up with a 0.2999 or 0.3001 and such. But the exact answer is just 0.3. This is true across all cases. Sine inverse of a number that can be fed to sine inverse is just x. Well, what kind of numbers can you feed to sine inverse? X's that are between 1 and -1. So this is kind of a general statement about the function and its inverse. It's like saying if you have a number, if you double it and then divide by 2, what are you going to get? You're going to get whatever you started with. If you have a number, you square it and then you take the square root, what are you going to get? Well, if you started with a positive number, you're going to take that number back. So when you have a function and its inverse composed with each other on the proper domain, you just get that number back. Let's do some more examples of these things. Essentially, 38 is the same story. It says, what is tangent inverse of minus 4.2? Let me rewrite this thing. My writing became unacceptable. Tangent inverse of minus 4.2. Again, we reason like this. What is this quantity? Let's bring it out and study it. Tangent inverse of minus 4.2. What is that? We are going back to the angle whose tangent was this. Let's call it, for convenience, theta. What does that statement mean? It means if you had calculated tangent of theta, you would have ended up with minus 4.2. Well, what is it that you are trying to calculate here? You are trying to calculate tangent of, and this guy is just theta. So we end up being minus 4.2. So this is same statement about tangent inverse of x. That's just x. Similarly, you could expect that cosine of cosine inverse of x, that is x, still with the same restriction. That is true across the board. If you have any old function, you calculated its inverse and applied that to the, gave it to the original function f, all that you are going to get at the end is the original number itself. This is a mathematical way of saying that if you are making a round trip, you come back to where you were. Like if you have some number, you apply some function to it, you get some answer out of it. So you had an x, you apply this function, you get f of x. If you come back, how do you come back? You come back with the inverse. If you come back with the inverse, well, you are going to end up where you were. That is saying that if you take a number, you give it to a function, and you reverse your activity, you come back to where you were. Same as this. If you start with a number, if you start at this destination, you come back with f inverse, and then you go with f, you end up at the starting location. So these are statements that a function and its inverse undo each other. Whatever one of them has done, the other one is going to erase. It's like you wrote with something. Suppose this is your pencil, this is your eraser. Kind of. You are undoing whatever somebody else has done. Now some of these problems become a little bit more involved because we have a domain issue, and the functions that we are using are actually restricted functions for the inverse, and to make it to become an inverse function, sometimes we had to do a little bit of a surgery. Sometimes we had to cut the domain and such. So we have to take these things with a grain of salt and be careful when you are doing some of the other questions in this section, such as what? The next range of these, next set of problems, you have to be a little bit more careful with them. Suppose we take 40. It says, what is sine inverse of sine of 2 pi third? Pi third is some angle. You can go ahead and try to find sine of 2 pi third. That is going to be some number. Now the question is, what is sine inverse of that number? So let's for the moment assume that sine of 2 pi third is some number x. In this case, we actually know what that x is. This is one of the famous angles. We know the answer is like radical 3 over 2. But never mind that. Question is, what is sine inverse of x? That's what we are posed with here. What's the sine inverse of that number? We are looking for the angle whose sine. So let me write. We are looking for an angle whose sine is same as sine of 2 pi third. But to be in the proper range of sine inverse, we have to make sure answer is in what range of numbers? You said what? Negative pi over 2 pi over 2. So maybe a unit circle approach is going to be helpful. We said that our vertical axis is the sine axis. If I have an angle, if I want to find its sine, I look at the shadow on the vertical, see what is that shadow. That is the sine of theta. If this is theta, that is the sine of theta. Okay, what is happening here? What is happening is that I have 2 pi third. Which quadrant is that in? 2 pi third, 120 degrees, I'm somewhere here. I want to know my sine. So how do I get the sine? I come here. This is the sine of 2 pi third. Now I ask, what is the sine inverse of this? The trick now is that whatever answer you give, it has to be something that is in quadrant 4 or 1 in this range from minus pi over 2 to pi over 2, whose sine agrees with the sine of the angle you just gave. So you gave me 120 degrees. I find the sine something here, like radical 3 over 2. Now I ask, what's an angle whose sine matches this and is also in this yellow region? So what should I say? So again, we are looking for an angle whose sine is same as this, but it is in this yellow region. So what do I do? Simple trick. Just go in either of these two quadrants and ask yourself, well, what is this angle? If this is 2 pi third, this is 60 or pi third. So sine inverse of 2 pi third is just pi third. So you have to pick an angle in fourth or first quadrant who match up to the angle you have. You might have gone around the circle several times. You might have gone into quadrant 2 or 4 and so on. You just have to bring it all to first or fourth quadrant and make sure your number is between these two numbers. Or if you're dealing with degrees, by the way, on the exam I noticed the problem that the students are mixing degrees and radians. That's a no-no. You can't write 30 degrees plus pi over 4. I mean, it's some fluky cases that somebody might really want that, but we almost never come across any such combination. Degrees for themselves, radians by themselves, and you almost never see pi when you're talking about degrees and so on. So be careful about the degrees that you got. Anyway, that is answer to problem 40. Now let's go do something that's going to be hopefully a little bit easier. 39. Cosine inverse of cosine of minus pi over 4. So again, let's go back to the unit circle approach. Unit circle approach, you say here we have this circle. You are calculating cosine. How do you calculate cosine anyway? Cosine you calculate it by drawing a shadow on the horizontal, and you call that cosine. So what angle are we given here? We are given an angle of minus pi over 4. Minus pi over 4 happens to be in which quadrant? This is my minus pi over 4. What is the cosine of it? Well, radical 2 over 2. This is the cosine of pi minus pi over 4. Now we ask, we want to operate in range of cosine inverse, which is what? The set of angles in which two quadrants are 0. Give me an angle in this standard range of angles from 0 to pi whose cosine matches the cosine of angle you got. So in this case we say, well, go straight up, find this one, and what you get is pi over 4. Excuse me, I have to take it. Okay. So the major issue is bringing your angle back to the range of angles that is defined for the trig function or the inverse trig function you are working with. So you have to be careful in these set of problems. With 37, 38, it's almost impossible to go wrong. In the next set of problems, without a calculator, it's possible to make some mistake. But if you use your calculator, that possibility also off the table. So finally, what's our answer to this question? Pi over 4. Pi over 4 is the angle. Again, we are looking for an angle in the range of cosine inverse, which is quadrant 1 or quadrant 2. You want your answer to be in the range from 0 to pi or from 0 to 180. Either of them.
I have a question.
Yes.
On the one you just worked previously,
Yes.
the one right above it,
Yeah.
why couldn't the answer was pi thirds, right?
Yes.
If you look at 2 pi thirds that's in the second quadrant, it needs to be in the first or the fourth.
Uh-huh.
Why is it that? Never mind.
I'm glad to be of help. That's why I get that paycheck. Just my presence by itself solves problems.
The knowledge radiates off of it.
Yes, it's like teleportation of knowledge or something like
Just stand right here while I'm taking the test.
Okay. Let's do another one. 43. Now we are skipping the ones with the other functions because we are short of time as it is. Tangent of 2 pi third. Again, the issue is try to answer these things without a calculator. Now, if a teacher wants to be nasty, there are ways. Okay, let's do this thing and we come back to how to be nasty here. But let's see. Tangent of 2 pi third. We said let's practice the unit circle approach. Unit circle approach, we have where was the tangent axis? It was here, you remember? What role did it play? The role it played is that if you have an angle, you want to find its tangent, you want to really look at something, so this is what we're talking about, you just keep going, this is your tangent. If you are up here, it's positive, you're down here, it's negative. This is really an axis that starts at this point. Notice that if you are at this point, you have to kind of back up until you hit the axis, and then you see your tangent. This also tells you, for example, in the third quadrant, tangent would be positive. Okay, what are we dealing with here? 2 pi third. Which quadrant is that in? 2 pi third, that's 120 degrees. This is 2 pi third. We are coming here. So that is our angle 2 pi third. If we are down here, well, we know what the tangent is going to be. Tangent is equal to the length of this line, but has to be negative. By let me see, by chance, does anybody remember what is tangent of 120 degrees? See, this gives you a kind of a ballpark, what kind of a number to look for. This is 1, so this can't be 1 1/2 or anything like that. Radical 3 or minus radical 3, whatever it is. Okay. Now the question is, for answering for tangent, we want to be in the correct quadrant. What quadrant is that going to be in? For tangent, we said we want to be in quadrant same as sine. So you have to give me an angle whose tangent is same as this, but is in the correct range of angles for tangent inverse. What would that be? That would be this angle. So if that is 2 pi third, what would this one be? So that we are done with that.
Why is it any different from sine? Like the answer to that same problem involving sine was pi third?
Yeah, because on that case, you needed to make sure your answer is positive quantity. Over there, tangent of that has to match tangent of this one. Over there, we had to make that the sine of this is equal to the sine of that one. So we had to go in the first quadrant so that our sine of pi third would be positive, just the same way sine of 2 pi third is. But since tangent of 2 pi third is negative, to match that, we have to be in the negative region. This angle will have the correct flavor to it. If you pick pi third, well, what is tangent of pi third? That's going to be in the positive region. It does not agree with what we have here. Next, let me see if you have any particular question. I'm just picking these things. Let's see if you have other question, you bring it up. But let's do. What if our functions are mismatched? It's not same function being used. Here is tangent. Here is sine. Now, let's go ahead and answer this thing first by assuming this is A, this is letter A. Let's suppose for the moment that we are dealing with positive quantities. Best way to answer this is to get a picture. If you say tangent inverse of A third is something, what are we talking about? Are we talking about angles, or are we talking about something else? Tangent inverse trig function, we are looking for an angle. With what property? With property that its tangent is A third. Now tell me, what kind of a right triangle matches this picture? What kind of numbers or letters should I put in this right triangle? So say this is theta. What can you say about any of these legs that would match the description that we have here? Opposite is what? A, adjacent, 3. Okay, if we get this thing quickly, then we can get the hypotenuse fast as well. What is the hypotenuse? Square root of A squared plus 9. Is that right? Or 3 squared. Okay, in this context, remember this was our angle theta. So sine, what we are asking really is, what is sine of theta? If theta is an angle such that its opposite is A, its adjacent is 3, such that its tangent is A third, what would its sine be? No, even if A was negative, this answer would be correct. That is, if A is negative, we are going down here. Hypotenuse is the same amount. Sine of that angle is still opposite to the hypotenuse. We get by the same answer. And so across all kind of possibilities, this is the correct answer. So what is the final answer here? Final answer is that this is A over radical A squared plus 9. And we got it by just drawing the right triangle. Let me see if I can squeeze in a couple more before we take a break. Let's
still have a ration right?
not really.
58. In the homework.
Is it asking you to ration? There isn't much to be gained by that. 58 is sine of cosine inverse of x. Let's analyze this. Suppose this is some angle. Cosine inverse of x is some angle. What does that mean? It means you were calculating cosine, you ended up with the letter x, with the quantity x. Let's draw a picture to get a handle on the situation. We just draw a right triangle. So some angle in it is theta, whose cosine is x. Now give me some designation for these three sides that matches what we have written here. Yeah, very good. X is same as x over 1. So if I call this x, I call this 1, I'm all set because cosine of that angle is just x over 1. What is it that you want? I want sine of that angle. Well, sine of that angle, I need the opposite to get that. Well, what's the opposite of that? Square root of? The other way around. You mean 1 minus x squared. So sine of this is the opposite over the hypotenuse, and what we get is 1 minus x squared. Now since cosine inverse is always in which quadrant can cosine inverse be? You remember that quadrants 1 and 2. What is the sign of anything that is in quadrant 1 or 2? Can it be ever negative? It's always positive. Always positive. So we never have an issue with the minus in front of this. This is a correct answer for all cases. Even though we are answering it with the first quadrant, the same formula applies even if we are in some other quadrant. Still fine. Now, as we go down this list, the problems become more and more challenging. Let's say take 62. This one, not only the functions are mismatched, but some modifications also being done. 2 cosine inverse of 3/5. Okay, here is our standard approach. What is cosine inverse of 3/5? What kind of a quantity are we talking about? It's some angle, is that right? That means it's an angle whose cosine is 3/5. Let's go get a handle on this. Cosine is 3/5. Tell me something about a triangle that kind of matches this situation. Something about the sides. What can we say? So say this is my theta. Adjacent has to be 3. Hypotenuse 5. Opposite, therefore, automatically 4. So we don't waste time on that. So we have sine of theta available to us easily. Is that right? 4/5. Okay. Now let's say this is sine of twice this angle. That angle is not one of those famous angles, but we have a good handle on it. We know a lot about it. Sine of 2 theta. Now all of these exercises then are going to kick back to the previous section. We still need sine and cosine of double angles, sum and differences, all of this stuff. Sine of 2 theta. Who remembers the identity for that? Good. Even though we had the exam, but you guys still remember. Very good. 2 sine theta, cosine theta. Well, do I know the value for these guys? What is sine theta? Say 2. This is 4/5. This is 3/5. What is my net? 2, 4, 3 makes 24 over 25, and that does it. Let's do one more before we take a short break. Everybody follow what happened here? Let's do 63. 63, we have cosine of sine inverse of radical 2 over 2 plus cosine inverse of 3/5. Now, not only we have mismatches, but also the angles are being added before you apply some trig functions to it. What's going to happen here? Well, we have 2 angles. Let's designate them by different names. This is it's a famous angle, but let's ignore the fact that we know it's a famous angle. Let's call it alpha. This is some other angle. We just dealt with that. Cosine of beta. So if I handle alpha and beta completely, then I can come back and say this is cosine of alpha plus beta, which is equal to what? Again, we need that identity. Cosine of? And what's the second piece? Sine alpha, sine beta. Okay? Now, what do I know about alpha? I know sine of alpha is radical 2 over 2. Well, let's not waste too much time on it. What angle is this guy? Pi over famous angle. I'm being a little bit fast on it. So what is the cosine of alpha? Cosine of 45 degrees, same thing. How about the second angle? Second angle, I know cosine of beta is 3/5. So what does that tell me about sine of alpha? We just went through same story over there. Sine of beta. What is, if I know cosine of an angle is 3/5, it's sine. We just did that. Cosine of an angle is 3/5. Its sine is going to be 4/5. Now, once we have all of these things, we can come back here. So cosine of alpha you want is radical 2 over 2. Cosine of beta it's given to you. It's 3/5. Minus sine of alpha it was just radical 2 over 2. Sine of beta is 4/5. Common denominator is 10. Numerator is 3 radical 2 minus 4 radical 2. Net of that is minus radical 2 over 10. Okay. Now let's take a couple of minutes and we continue with examples from 2.5.